Alright, let's look at the practice exam 3, problem number 10, part B. Alright, so let's test this series. Alright, so what I'm going to do is I'm going to use a limit comparison test on this one. Alright, so if you look at the just the leading coefficient on a leading term on top, which is a square root of n cubed. And on the bottom, you don't even have to worry about the coefficient here. So you have n squared. So I'm going to let Bn, so here, this is the series that I'm going to compare with. Bn here is going to be square root of n cubed over n squared. Right? Which can be rewritten as n to the, square root is 1/2 power, so it's a 3/2 power. And on the bottom, you have n squared, right? So this is going to be, so cancel, n to the 3/2 power. You're going to get the 1 over n to the 1/2 power, right? So we know that if you look at the series with this Bn, so Bn, alright, so this is going to be summation with 1 over n to the 1/2 power. I guess I have to put n equals 1 to infinity. Here n equals 1 to infinity. Alright, so this guy, we actually know that this guy diverges by P series test, because this is a P series, right? So P, not S, P series. By P series with, actually maybe I should say P series test with, in this case, a P is 1/2. 1/2 is definitely less than or equal to 1, right? So therefore, we get a divergence, right? So the next step would be we have to make sure that the original series is comparable with this Bn that we came up with, right? So to establish that, we need to do this limit as n approaches infinity. Right, so this is going to be our an, right? So this is going to be our an, right? So we're going to have to do an over bn. All right. All right, so this is going to be, let's see, you have a limit as n approaches infinity. Alright, so an is just the original one, so I'm going to just put, I'll just copy this. So it's a square root of n cubed plus 1 over 3n squared plus n plus 3. Alright, then divide by bn. I'm going to multiply by its reciprocal. Alright, bn is this guy right here, so I'm going to put n squared on top and square root of n cubed. I like this form better than the simplified form. Alright, then next thing we do is I'm going to just group things together. So you have limit as n approaches infinity. Alright, so both of these guys have square roots. So I'm going to put it under the same square root. So it's going to be a square root of n cubed plus 1 over n cubed, right? And the rest of it is just n squared on top. Then you have a 3n squared plus n plus 3. All right. To evaluate this, all we have to do is this. Let's see. For this one, I'm gonna multiply top and bottom by 1 over n squared. Right? It's the trick we've been using. All right, for the square root one, I'm going to just split it into two fractions here. So you have n cubed over n cubed plus 1 over n cubed. All right, so if you do that, you're going to get this. All right, so you have a limit as n approaches infinity. All right, you have a square root. All right. Then n cubed divided by n cubed is 1. And a 1 divided by n cubed is 1 over n cubed. Right here, I'm going to just go ahead and distribute this guy there. You're going to get 1 here. Alright, then I'm going to distribute the 1 over n squared to each term. Alright, then you get 3 here, and plus 1 over n, and then you have a 3 over n squared. Alright, then this is the easy limit. We know that this guy approaches 0, and the 1 over n approaches 0. 3 over n squared approaches 0. Alright, so what you get is going to be square root of 1 times 1/3. So it's going to be 1/3. Right, which is the finite number. All we need is a finite number. Right, so the ratio between an and bn is about the 1 to 3. Right, 1 to 3 ratio. Right, so whenever one diverges, the other one diverges. Whenever one converges, the other one also converges. But in this case, we know that here, the one we comparing with diverges. So the original one also diverges. I'm going to actually move this guy a little bit here. So I'm going to just, let's see, I'm going to move this down here. All right, then I'm going to just say, so this guy diverges, right, by limit comparison test. All right, so that is the answer here. All right, that's it. I hope that this was clear.